Good afternoon. Welcome. This is a webinar sponsored by the Minnesota Bankers Association in cooperation with Minnesota Farm Business Management. Eric Snodgrass is our featured speaker today. He is Principal Atmospheric Scientist for Nutrien Ag Solutions. I think some of you have been fortunate to be a part of his presentations in the past. He does a wonderful job of bringing climate and agriculture together, give us perspectives of what we saw this past year is perhaps what we're going to see going forward in the coming months. With that, I would ask from just a courtesy standpoint, keep yourself muted. I will mute if needed, and as well, keep your video off. If you have questions, you have a chat feature down on the bottom. I would ask that you would just simply put your questions in that chat feature, and then Eric, I can help you towards the end if there's questions that have come up that we can answer towards together. Be aware that we are recording today's seminar, our webinar going forward. And with that, Eric, I welcome you to this particular webinar. We're very pleased to have you, fortunate, and we look forward to what you have to say. So with that, Eric, if you want to step forward, we'd appreciate it. Thank you.
All right. Well, I appreciate the invitation to come and speak, and I'm going to tell you something. The beginning of my talk today is courtesy of a television show that I finished watching about a month ago. So every talk I've given over the last month, I've started off the same way because I got kind of turned on to this TV show just by happenstance. Someone asked me, had you ever seen this show called Clarkson's Farm? And if you're unaware who the Clarkson is I'm talking about, it's this Clarkson. That's Jeremy Clarkson. And he's famous for, being a kind of a British, TV personality. Probably his most famous show was Top Gear. He was one of the three main, hosts on that show, along with Richard Hammond and James May. And he's, famous for driving really expensive fast cars, around a track and power sliding them and getting into all sorts of trouble with his co-hosts. Okay, so in 2008, according to the show, he bought a 1,000-acre farm in England. And he decided to have the Amazon crew follow him around during the 2019 and 2020 growing season, where he, after now ending kind of his career on Top Gear, was going to learn to farm. And I'm going to recommend, if you've got Amazon Prime, just to go watch it. But the only thing I could tell you about it is the language can get a little rough at times. So if that bothers you, just know about it. But you're going to meet some amazing characters along the way, like Charlie, his farm manager. This is Caleb over here on the right. He is the guy that basically teaches Jeremy how to farm. And it is a hilarious relationship that those two have. And my favorite character is Gerald. He's kind of a jack of all trades, but one of his trades that he cannot accomplish very well is speaking. And you can't understand a word that he says, but you'll fall in love with the guy. Now, the reason why I'm showing you this is because this isn't a spoiler alert, but the very last episode of season 1 had a scene that just kind of floored me. And I'd like to show it to you. And because I think that in this scene, not only did I learn a valuable lesson, but it's a constant reminder of the business that we are in. So I'm allowed to show up to a 3-minute segment of any show without violating copyright. So I saved it and I want to show it to you. Are you ready for this? Here we go. This is one of the very last moments in the show called Clarkson's Farm. And there's a valuable lesson in this for me, and I hope in there for you as well. So here we go. This is Charlie. And as I click play, he's going to have a conversation with Jeremy Clarkson at the end of harvest. So here we are.
We're all done.
End of the harvest.
Well done. Good.
Well,
how does it feel?
I'll let you know in a minute because you're going to tell me the figures. You're going to give me the moment of truth.
Well, as you know.
As we know, here we go.
It hasn't been a great year for farming generally.
I read in the Times yesterday it's the worst year for farmers since 1976.
Dry summer. I know. I remember it well.
It was the year of my O-levels, is why I haven't got any.
So we're just going to look at these top boxes. Look at the blue. Now I'm going to frighten you. Last year, we made £226,000 from crop sales. That's before any costs. So £226,000. Yeah.
And this year's 137.
So £90,000 lower from the same area.
Which is
Which is quite incredible. So,
well, incredible's one word. That is £90,000 down.
It's enormous. 40% lower.
£90,000 gone because of the weather. So where are the costs? Because how much, here are the costs then. So we spent £14,000 on seed, 34,000 on fertiliser,
and
20,000 on spray.
so £68,601. And then there's £68,457 of costs. That's Caleb. That's the machinery. So you've made £144 profit from the arable farm.
So the fact of the matter is this: farming 7 days a week for a year from a 1,000-acre farm has generated an income of £144.
Correct. Fortunately, at the moment, we have this subsidy. When that goes,
What are farmers going to do? I mean, honestly, what are they going to do? The ones who don't have Amazon film because he's from them around and who wants to be a millionaire to top up the income. I mean, what do you do when these subsidies start to go down?
there's going to be a sea change to the rural, the countryside. There'll be 30% less farmers probably.
But that's where we are with farming in this day and age. And the next time a farmer moans about the weather, put your arm around him and buy him a pint, because he's not moaning about it because it's a bit miserable working in the rain. He's moaning about it because it's crucified.
So when I saw that, I was just almost flattened. Jeremy directly talks to the screen here after seeing that his balance sheet after a year of farming made him 144 British pounds. That was the net profit. I know every one of you has seen one of these, charts that's in the background here, one of these, tables that tells you exactly what your expenses were versus production and total farm income. And it's just a reminder that the business we're all in here is got considerable sources of risk. And I've made a career out of trying to understand one of those sources of risk. And it was the biggest one that he had here in 2019 going into 2020 was the weather. It was record wet in the fall when he planted his wheat and barley and oil rapeseed. And then it was record dry in the following spring and summer when he needed to get the yield out of that ground to harvest it. And I highly recommend you all watch the show. It's on Amazon Prime. I loved it. And my wife even sat down and watched it with me. But I just want to remind you, ultimately what I attempt to study is represented on this map. I went from 1980 to 2020. I looked at every county in the country that produces corn. I just chose corn because where I live right here outside of Champaign, Illinois, we are corn and soybeans as far as the eye could see. And what I wanted to know was, what's the normal variance around the average? And I color coded it. The places that are in the darker red colors are places that have very high variance, which means year on year, yields change a lot. The places that are in the whites to blues have lower variance. In fact, the blues are the lowest. And those tend to be places where we have a lot of irrigation efforts that go on. But the reality of this is that as we look at all of these different places and the way that weather influences them, we have to just remember that weather factors like this supercell thunderstorm you see here from Texas a few years ago, while they may be, affecting a very small area in a massive way, this is just one of the many types of weather that we observe, from severe storms to frost damage to ice storms to massive blizzards to heat waves. You got to remember, weather spans 18 orders of magnitude when you look at the scale size of weather events. And so to be able to predict these kind of things and know where they're going to be is of utmost importance to everybody on the call today. But it is one of the greatest challenges facing, and I'm just going to toss out the word here, science. It's one of the greatest scientific challenges, predicting the future behavior of a nonlinear chaotic system. That's our atmosphere. It's one of the greatest challenges that we have. And therefore, it's going to remain a source of uncertainty. Now, just to clear something up, because it is fall, I don't know, honestly, where this came from a long time ago, but every fall, people ask me about the validity of the woolly worm forecast. What's funny is every year I'll get people that will send me pictures of very brown woolly worms like the one on the left there and say, oh, we got a bunch of these around our part of Iowa. We're expecting a brutally cold winter. And then from the same part of Iowa, I will have people send me pictures of a black woolly worm. And they'll say, look, there's black woolly worms this year. It's going to be a brutally tough winter in our part of Iowa. And I look at it and I want you all to remember that there is no predictive skill in the coat of the woolly bear worm here, which you see. For example, if there was, what does this mean? That the front half of winter is going to be terrible, the middle half will be perfectly fine, and then the end is going to be terrible again? Or what happens if you find one that looks like this? Is that going to be one of those winters where there's a ton of ice and then, halfway decent conditions at the end? I really have no idea. And that's because these particular creatures have no predictive skill on the weather. I just want to let you know something. Not only did NOAA, National Organization of Atmosphere, NOAA, not only did they study this, but they also studied the persimmon nut. I often get asked about people that crack open a persimmon nut and they see on the inside certain types of cutlery, be it spoons or knives or forks. And they asked me, well, this year I found a bunch that have knives. What does that mean? I said, it doesn't mean anything. It just means that the middle of that nut is shaped more like a knife than anything else. And just as a quick reminder, because we're going to keep looking for this stuff all through winter into spring, next February 2nd, we're going to yank this this creature that should be hibernating out of a cage and ask its opinion about its shadow, which I'm pretty sure it is unaware that it even has a shadow. So it's just interesting that we do that. And while we're on this kick, about a month ago, I got asked if the government sprayed you with aircraft. No, they don't. And also time travel is not completed with a lightning strike and a DeLorean. So we're all clear on those things. Let's now get back to business here. Okay, Farmer's Almanac, interesting resource. I don't know who makes the forecast that goes into the Farmer's Almanac, but I get asked about it a lot, so I thought we would address it. This is what the forecast was for last winter. Now, if we just take a look at the northern plains, the forecast was for cold with above normal snowfall. In the southern plains, temperamental, wild swings from mild to tranquil to cold and wintry. And if we just think about this area, that from there to the upper Midwest, someone might go back and look at last year and say, well, you know what? There was that one event, right, back in February, where around this big high pressure cell, the flow came around like this, all the way through the Canadian prairie, all the way down to the Gulf of Mexico before it turned and came back up into the Tennessee Valley. We call this kind of flow cross-polar flow. And when that happened, it certainly made the weather conditions temperamental, because for about a 15-day time period from the 5th of February to the 20th of February, there was a section of the United States in through here that averaged 20 to 30 degrees below normal in terms of temperature over that long stretch of time. So yeah, it was certainly temperamental in the southern plains, but it said it was going to be a really cold winter and snowy winter for the upper Midwest, for the northern plains. And when we look at that one event, that dominated all the winter news headlines. But up until that point, we favored more warm days when we looked down there to that cold air that got clear into Texas than we did otherwise. In fact, you go north, December through February, look at this. We've got 126 years in this data set from NOAA. And it showed that the state of Minnesota had its 108th warmest out of 126. So the Farmer's Almanac said it was going to be cold, but it wasn't. It also said it was going to be snowy. We missed out on a lot of snow in North Dakota, South Dakota, Montana, northern Minnesota. We had a couple of bigger systems that went through central Minnesota, but that was the only place in the upper Midwest that showed near normal to above normal snowfall last winter. This was absolutely critical to the spring flooding problems that we can sometimes get on the Missouri River or on the Mississippi. We didn't have all that snow to melt to get into that river system. And as a consequence, we had lower prevent plant acres, but we had drought, no moisture replenishment early in the season. So just thinking about it, might as well look at this year, because what it's calling for you this year is numbs the word and just shoveling along. And where I live, icy and flaky. I'm not sure if that's a comment on my personality or what, but look at this, numbs the word, just shoveling along. And what's funny is I don't actually disagree with it this year, nor do I disagree with this. Now, I don't know if between last year and this year they hired a new meteorologist, but there's a lot about this that makes a lot of sense to me right now. And I want to talk to you about that in just a few moments. But I told you in the description, excuse me, of today's talk that I really wanted you to hone in and understand what we call the limits of prediction. And I hope you find the next 2 minutes here fascinating, because I'm going to tell you about this guy over here on the left. His name is Edward Lorenz. And in the 1940s, he published a paper that talked about how far into the future we would be able to accurately, which means within a 3% error, how accurately we'd be able to predict the weather. Now, what he was talking about was a point forecast. In other words, if I was just going to pick out the forecast for Minneapolis, what is the theoretical limit of prediction for a forecast there within 3% error? Now, what he discovered, and I want you to remember this, is that he said even with perfect technology, perfect observation, that our weather forecast models would only be able to see accurately into the future out to about 21 days. And we're nowhere near that right now. Want to see where we are? This comes from the European model, okay? The 3-day forecast from the 80s to now has gone from being about, we'll call that 80, 85% accurate to be about 97%. The 5-day forecast is currently sitting at about 92% accurate. The 7-day, 78. And look at this, the 10-day forecast right now is about 50-50. And this guy said even with perfect technology, we couldn't get up to an accurate forecast beyond 21 days. And I think it'd be kind of fun to prove this guy's research now in 2021. Are you ready for this? Here we go. This was back on October the 13th. I just saved off this one case study to make a point here. We had a deep low pressure system that came out of Wyoming, severe weather to the south, very windy southerly winds coming in here, a lot of cold air wrapped around the backside of that low. It was a blizzard and a disruptive one back on October the 13th. It did this in Montana. You can see the heavy snow there. And in Idaho, this is what the Redfish Lake Visitor Center, which is near Pocatello, was showing up with snow. Total amount of snowfall, we had places in Wyoming, the Western Dakotas, Montana, between 6 and 24 inches of snow. And by the way, to the south, major severe weather outbreak down here, 15 different tornadoes. Most of them came from this squall line here going toward Dodge City, Kansas. See it right there? There was a tornado actually on the backside of this that did a lot of damage in Sharon Springs, Kansas. My point behind showing you this is that this was a very disruptive storm system. I remember it well because we were right just at this point getting a good head of steam going on harvest in my part of East Central Illinois. And this rain that came through not only caused major harvest disruptions, but the heavy rain that we got from this one and following systems started to cause problems with soybeans lodging. We even had some of the soybean pods kind of pop open with the really wet conditions. And it really put a terrible finish on our growing season. Now, Minnesota, you didn't get much out of this. It really hit the northern plains and the southern plains through the Midwest the hardest. But this is our lesson for today. You ready for this? I hope you find this fascinating. Whenever we look for the pieces of the atmosphere that have the potential to create adverse weather, we look for what are called troughs in the flow of the jet stream. We color code them blue because they're troughs of cold air. And when they displace ridges of warm air, you get rising motion. So we always watch for where the troughs, in this case indicated with the yellow arrow, are moving. There's actually several on the graphic, but I only want you to watch the one that I'm going to indicate with an arrow. Now, what I'm going to show you here is where that trough was each day before the 13th, going back 12 days. Are you ready? As I click play, the arrow will begin to move. So on the Tuesday, it was here. The day before that, it was in the Northwest. The day before that, British Columbia, Gulf of Alaska, Aleutian Islands, Bering Sea, North Pacific. And it started out there in pockets and places in the North Pacific just as a very small, weak disturbance. And going all the way back from the 13th of October to the 2nd of October, it was that small little wave right there. And that's just north of Japan. What this blizzard that happened on the 13th that was here was, beforehand, was that little thing. And before that, it was this. That's right, it was a typhoon. And 2 days before that typhoon was here, just off the coast of Japan, it was there. 2 days before that, it was here. 2 days before that, it was there. And 2 days before that, it was here. 21 days before it became a high plains blizzard, it was this very weak little disturbance coming out of the tropics a half a world away. Shows you how connected everything is. It also shows you that if I went back another day before this, I can't find this feature. It's gone. And my point behind this is what Edward Lorenz understood was the traceability of any weather system back in time almost always hits a hard limit around 21 days. And that's because the world's complicated with mountain ranges and massive oceans and deserts. It's got flow that's complicated with the fact that the whole planet, which is round, despite what some people say, is spinning at an incredible speed. At the equator, it's rotating at 1,024 miles an hour. So we look at all of this and just say something. Predicting your day-to-day weather more than 21 days in advance is the theoretical limit that we will never be able to get past. And where are we right now? We're pretty good at about 7 days at predicting your day-to-day weather. Beyond that, we have some tricks up our sleeves where we can improve the probability of giving you a forecast of it being wetter or drier, warmer or colder. But the reality of it is, Edward Lorenz was famous for making one quote about predictable systems. He said that in the atmosphere, because of chaos, it tends to be a system that is going to exhibit the butterfly effect. Y'all remember hearing about the butterfly effect in chaotic systems? The idea is that if a butterfly flaps its wings in Brazil, it could produce a blizzard in Russia. Well, that's just what happens in nonlinear systems. Small little changes, or what we call perturbations, can sometimes grow upstream to become something much, much bigger. Now, the reality is a butterfly flapping its wings can't do that. It's dampened out by friction. But this is a pretty big butterfly. And it flapped its wings into a typhoon, which became an extratropical cyclone in the Bering Sea, went across the Aleutian Islands, dipped over the mountains, and became a blizzard in Wyoming. And there's not a soul on the face of the earth that on September 22nd said, look, there's a high plains blizzard on October 13th. We are not capable of doing that. What are we capable of doing? Well, take a look at this. Now, I know I'm getting a little technical here, but watch. Ready? This is a 16-day, almost a 16-day forecast, valid on the 13th of October, the day that there was a big low-pressure system right here that brought the severe weather to the south and the snow on the backside, right? Just 16 days before, the models weren't even forecasting it there. And watch this. I'm going to go one day at a time. This was 15 days before, 14, 13, 12, 11, 10, right there. I'm going to pause it. At 10 days out, we started to see, whoops, one too many. There we go. 10 days out, that's when the model started to pick up on this. And then as we kept going, look, at 9 days, 8, 7, bounced it around a lot, right? Changed the precipitation type. Even 3, 2, 1, 12 hours before. It was still showing a lot of variability in the forecast. This is the best model we have running in the United States, and it only picked it up about 10 days out. Just want you to remember that that's how this stuff works. Now, we've talked about the limits of predictability, so you understand that it's a pretty rare day that I feel like this kid when forecasting the weather. Dad pitches the ball, hammers it out, shoots it on its way out, bat flip, and mom gives him a big pat on the back, right? It is rare that we feel like this every day, that we're able to perfectly predict the upcoming situation beyond 7 days or beyond 10 days, or even, as most people want, a month, 2 months, 3 months out. And I do know that a lot of people think there's a lot of like wizardry in this. And I'm going to tell you something. It takes years and years of experience and studying to figure this out. And no, we just don't scoop it up and shove it into our heads like this young boy here thinks he's reading right now. It just takes a lot of pattern recognition to figure this out. Now, with that as a setup, what I want to talk to you is about what 2021 gave us, and then we're going to get into a forecast. And we're going to talk about South America and Europe, which are going to be critical to the upcoming market story here in a few minutes. But 2021 was expensive. We had 18 separate billion-dollar weather disasters. And the good news is that this year, not one of them was in the state of Minnesota. We had severe weather outside of it, and there were some nasty storms that came through, but we avoided the big weather disasters. We did not avoid drought, though, this year. And I'm going to talk to you about that. You see, this map, there's a number inside of every climate reporting district. And the number represents where the rank is on the 129 years that we have in this data set. This data set is compliments initially from the U.S. military, which thank goodness they hired weather officers at every military base across the United States to start keeping records. Because before the National Weather Service was formed, this was the mainstay by which we got this information. What you need to see here is that throughout the state of Minnesota, we either had a top 5, top 10, or top 15 warmest starts to summer. That would be from June 5th to August 15th. We accumulated heat very quickly. I'm going to show you where to go to get these graphics. I'm generating these for 30,000 places across the United States as a test bed right now, but take a look at what you've got. It's a graphic that shows you from the beginning of the year, January 1st, to present, how quickly we've accumulated GDDs. I also put on there 2020 through 2016 in different colors or different line graphs. You can see the black line here is 2021. Compared to the previous 5 years, and I chose this for Albert Lea just as an example, we had the fastest rate of accumulation of heat in terms of GDDs since, or at least over the last 5 or 6 years. We had the blue lines here, by the way, represent when we have the last frost on average and the first frost over the last 40 years. But to date, we've accumulated over 3,200 GDUs. And before we got that first frost, we were almost at 3,000 GDUs total accumulated this year. So the heat came on. The problem is that the drought that was in the Northwest expanded. It expanded through Montana, through parts of the Dakotas. And from June 1st to June 1st to August 15th, look at the numbers here. We had one climate reporting district, this big one up here, kind of in the Bemidji area north, that had its driest June 1st to August 15th on record. In the other reporting areas, most of them are having a top 5 driest. Again, this is at 129 years. Where I live over here, we couldn't shut the rain off at times. Same thing for Michigan. Same thing for down here in the south and across the Cotton Belt. We had just extensive drought that had a hard stop right about there on that line. Pretty impressive to see that. Now, in terms of precipitation, I just went ahead and chose this again for Albert Lea. We can compare the previous years to average, which is the dashed line. And you can see that throughout the month of let's call it mid-July to the end of August, extremely drying through this area. We were at one point at about 65% of normal precipitation. It then rained like mad at the very end of the month, taking you almost back up to average. And yes, that did help save the crop in parts of the southern parts of the state, but it was nothing like we'd seen the previous years where we had overall been quite wet. This is our first really significantly dry year in a very long time, at least over the last 6 years. Again, I'll show you where to make these graphics at the very end. If one of you will remind me, I'll make sure and show you that. What got us there this year was this factor. By the end of June, look at this massive ridge in the flow of the jet stream here. The jet stream went way up here toward the Arctic Circle, then dove right here through parts of the Dakotas and then curled back around. Problem was, Minnesota's right in through here. And when you have a big ridge like this, there's a lot of what we call upper level convergence in the flow there. You always want to be, I'll draw a little dashed line through it. You always want to be in this area if you need a lot of rain. Downstream of the trough, that's the dashed line. You were too close to the ridge this past summer. And as a consequence of that, it was a very hot and a very dry summer. And as a result of it, the West began to burn. Now, the West burns every year. This is a part of the natural cycle of the forests in the West. But when the smoke from these fires gets all the way into the Midwest, we begin to have a lot of problems. This was July the 19th, and you can see the extent of the wildfire smoke curling around that big ridge. See how it's all moving clockwise? And some of that smoke got all the way, of course, over here to Minnesota. One of the worst fires was this one in Oregon. Smoke from that fire went clear up into parts of Saskatchewan, made the turn through Manitoba, came straight out of the north, and went over parts of Minnesota. And also came over my home state of Illinois. So you on the call, do you remember back at the end of July when the sunsets were like deep, deep red and the sun would set way above the horizon into the smoky atmosphere? This was the fire that did it. And some of those fires, like the one you're watching here in California, produce what are called pyrocumulus clouds on top of them. Massive cumuliform clouds full of lots of little itty bitty tiny droplets of rain that don't fall out. They're too small to fall out. So it doesn't produce any rain, but it does produce a lot of static electricity and buildup of static charge and lightning. Now, this smoke got all the way to the east as well. I took this picture back at the end of July flying into Charlotte, North Carolina. Charlotte's only 3 miles away in this picture. Normally I could see it clear as day, but the smoke was so thick. And we forecast this. And in my reports, I show you what the forecasts are going to be. This was July 21st. You can see the western wildfire smoke coming right over the ridge, just covering parts of Minnesota. Now, we're in the middle of a study on the effect of this smoke across parts of the Midwest. And I've got some preliminary information to share with you. When we look at the 30 days that go from the 2nd of July through the 1st of August, now that was a dry time period. But we see that right in through here, there was a reduction between 1,000 and 2,500 watts per meter squared. Now, why that's so important is this was all from the wildfire smoke, which is why you see all these blues over here curling around and coming in through this area. And that wildfire smoke up to this point removed effectively about a day and a half in southern Minnesota, removed about a day and a half of total accumulated sunlight. So what that meant was, now it was spread out over a 30-day time period, but it was as though during that 30-day time period, the sun didn't shine for a full day and a half. That's how much we missed out on. I know it doesn't look like much, but that's quite a bit. It was really here in the Northeast and this whole area in the West that really suffered a lot from that loss of sunlight. So we're continuing to study what the diffuse sunlight and the lack of strong direct sunlight did to maybe the quality of the crop. But when you compare it to average, the 2021 fire season burned 6.6 million acres. Average would be 7. And it was nothing compared to a year ago where almost 9 million acres had burned so far in the year. So I just want to bring that up to you. And since we're talking about California, just look at this in the next 30 seconds. California, at the peak of their drought this year before it started to precipitate again, Lake Shasta and Lake Oroville, those are the two biggest reservoirs in the northern part of the state, were only at 22% of full pool, which meant for a lot of our friends in California, they did not have access to irrigation waters this year. The allotments didn't come through because the reservoirs were so depleted from this 3-year drought that we've seen in California. And by the way, I was just in Las Vegas, which is over here, okay, in Nevada. And I was trying to explain to somebody this longer term trend that's going on here and how the evaporation rates can get so high. And so we were near the hotel, the Bellagio, and they have an 8-acre pool that's out in front of the hotel. And it has those beautiful fountains in it. You've either seen them or you've heard about them. Well, it turns out that those pools every day during a summer like we had in 2021, they lose around 250,000 gallons of water to evaporation alone. So it just shows you the kind of situation we have there. Now, we've been studying these longer term trends, and I really want you to listen carefully with what I'm going to share with you over the next minute or so here. What you've got here are what we call the new climate normals. At the beginning of every decade, we reassess the average temperature and precipitation by day, week, month, year, or even over that entire time period. What you're seeing here is what happens when we dropped off, when we dropped off the time period of 1981 to 1990 and included 2011 to 2020. The adjustment there, looking at the change in annual mean temperature, meant that most places, with the exception here of parts of the northern plains, have now seen an increase in temperature. And if you look here, really most places that are west of that line saw a drying trend, while places to the east got wetter. And we got to talk about this because this is from NOAA, the new climate normals. I start to get asked, or I like to answer the question that I get asked a lot as to why, what's going on. And really what's happening here is that we're seeing a long-term systematic shift in the jet stream pattern. It was published in the journal Nature, but many of us have repeated this research. And you see up here in red, this is an area that over the last 70 years, we've trended toward more ridges in summer. So the jet stream has to go around that. And then it comes diving into the Great Lakes. So there's been more troughs of lower pressure here. And this long-term climatic shift has made most places west of the Continental Divide drier and most places east of the Continental Divide wetter with time. And I want to talk to you about that because we start asking ourselves, why is that the case? And this is a current map of ocean temperatures. Well, it was about a month ago. It doesn't matter. What we're looking at here is one of the big reasons. The North Pacific Ocean, that area right there, has seen an increase in its total temperature content since the 1970s. And as the ocean temperatures change, so do our weather patterns. And we're watching that very carefully as a culprit. Now, let's give you some numbers for the state of Minnesota. April to October, which we'll define as our normal growing season, I made a graphic here that's from NOAA that goes back to 1948 to present. The reason why we start at 1948 is that's the beginning of the modern reanalysis time period. And that's an important time period in atmospheric sciences where there were industry standards on data collection. And what you've got here is that over that 70 plus year time period, we've seen an increase of our growing season precipitation by about 4.5 inches. What's interesting is the last 2 years, here's 2020 and 2021, these two have been well below trend. And I just want to point out that historically, going back over this last 73 years, there's only been 2 other time periods here in the mid to late 70s. So this would be, this would be 77. So 76, 75, and 74, those 3 years right there, plus 87, 88, and 89, where we saw more than 2 years of below normal precipitation. So the likelihood of us having a third year of this is relatively low. We need to talk about what could control that here in just a few moments. But I need you to remember this graphic. For the state of Minnesota, I used radar data going back to 1981 to look at the frequency of our big rainfall events. Do you remember back at the end of August, we had all of the severe storms and extremely heavy rainfall that returned in some places 6 to 10 inches of rainfall? What we've learned is that since 1981, that the frequency of heavy rainfall events defined as 2 inches of rainfall or more per day has almost tripled in the state of Minnesota. Well, what that means is while we're getting more precipitation, you saw that here, on average during the growing season, more of it is coming from big rainfall events followed by longer stretches of drier weather. That's right here in the data. This year, what broke our drought was some severe weather. Now, 2021 will not be remembered as a year with a lot of severe weather. For example, in 2020, we had nearly double the reports of severe storms, but there were 29 tornadoes, 147 reports of hail, and 226 reports of severe wind this year. And each dot represents where they are. The red are tornadoes, the kind of green yellowish are hail, and the blue, are severe winds. The whole country was down this year compared to average on hail reports, less than half. Normally we had about 8,000. This year we were below 4,000. But there were some places that got hammered with hail. And I just want to take you to Texas real quick for a lesson. On radar, when you see these nasty storms, look for the pink and the purple. See it right there? The pink and the purple tells you where the radar is scanning through hail. We actually make maps of this, and I tell every one of our customer growers where they have seen hail. And the storm that just north of Dallas right here was one of the billion-dollar disasters last year because it produced hail damage from baseball-sized hail like this all over the northern suburbs of Dallas and Fort Worth. Now this year in Minnesota, we didn't see that. We also didn't see a lot of tornadoes this year. Where were we? Nationally, we were about 90% of normal. The biggest tornadoes were down south. And you can see here from this video footage from Brian Emfinger chasing back on May 2nd with his drone. Some big, nasty storms were down south early. But I want to tell you something about Tornado Alley. When you think about traditional Tornado Alley, which goes from Texas to North Dakota, Colorado to Indiana, there's been a shift systematically over the last 40 years such that we've been having better, well, I don't know if better is the right word, but more favorable tornado days east than west. Traditional Tornado Alley is shifting into the Mid-South, the Midwest, and the Upper Midwest. So if you see these colors, that would indicate better or a higher frequency of more favorable tornado days. So let's not forget that. We did experience some pretty nasty windstorms this year. And while it was only about 90% of average on winds, I want to show you one of those really nasty events here in just a few minutes. I maybe got my slide out of order here. Before I show you that, though, take a look at this. This would be hurricane season. We'll come back to that in a second. We exhausted our name list again this year, hit 21 named systems, which our last one was named Wanda. The worst was Hurricane Ida right here, came into Louisiana, Mississippi as a very powerful Category 4 strength storm. Pushed in a bunch of water. This is what it looked like in New Orleans. That's storm surge. That's not rainwater. And as the rainwater, though, was getting pushed by 85-mile-an-hour winds in New Orleans, this is what it looked like for about 8 straight hours. Incredibly nasty storm. The winds in this were so strong. Take a look at this. Are you ready? The Mississippi River down in this part of Louisiana normally discharges at a rate at around 350,000 cubic feet per second. There was a short time period right here, though, where the winds pushed against the Mississippi and the discharge rate went negative. The water built up an extra about 8 or 9 feet, and then it discharged out as soon as the winds went away. So speaking of those winds, now let's come back to those severe storm reports. We had a pretty rough go of it in much of the Corn Belt at the beginning and again at the end of August. This was the beginning. Each dot here represents a different severe weather report. And in Northern Illinois, my home state, we had a lot of corn that was damaged by these strong straight line winds. And I think we've all seen stuff like this. There was actually structural damage to the crop here, ripping those cells apart, and this did not recover. But one storm system I won't forget that came through Minnesota and Wisconsin was this one on August 24th. As I click play here, you're going to watch this leading edge of this squall line come racing through parts of Minnesota. And as it got into Wisconsin, there was a lot of crop damage from that particular event that came through there. Just remember those squall lines, when they take on a structure that bows them forward like that, you want to be very careful at the apex of the bow. That's where the strongest winds are. Now, in my last 20 minutes or so here, or 15 minutes or so here, I want to cover the forecast. Because we know that in June, Big Ridge parked here and the flow had to go over the top of it. That's what gave us dry conditions. But then once we got past August, the flow switched, and it did that, came out of the southwest, and the Big Ridge sat here. And the net effect of that was to send these massive winter storms into the northwest, like this one you see back here on October 25th, that then run over the mountains and cause major problems in the Midwest. Take a look at what that one did, though. Remember how me telling you Lake Oroville was so low? Well, Lake Oroville, which dropped 100 feet from its peak in May, added 40 feet of water in just 2 weeks from those big onshore flow events. And look at how it extended into the northern plains. So after being so dry, once we got into the month of September and October, November, we went over wet, and this was very disruptive for harvest. There is a silver lining to all of this. Soil moisture values before all of this were down in the 2% range at the beginning of August. This is the latest update right now. We have, in effect, brought our soil moistures back up and eliminated some of our major long-term concerns about drought continuing across Minnesota as we go into this winter. There's some good news there. We brought that soil moisture back up. We've also seen some snow, and some of that snow was very disruptive about a week and a half ago. This is how much we've accumulated so far on the season. Many places here have seen at least 1 to 4 inches of snow, but when you get into the northern part of the state, we've been over a foot so far. You compare that to average, we're below normal when you get south of that line, but above normal in this particular area, just to this point. Just made this map this morning. Now from here, let's talk about our temperatures. We forecast and we'll wrap this up. There's no doubt that the front half of October was really, really warm. That big ridge over Greenland kept us that way. The big storm systems going into the northwest kept them cold. But since then, the pattern has shifted. We see more ridging over the southwest. We've had a lot of cold air at times come out through the northern plains down into the southeast. So this is November 1 through the 21st. On the precipitation side of things, we've maintained near normal precipitation in Minnesota. This has been disruptive of fall fieldwork. This has been slowing up harvest, the late harvest, but overall it's helped to improve our soil moisture. But you notice how it's dry here and dry down here, right? We need to be talking about where that's going to go. Because as Keith and I were talking beforehand, at least the next 10 days favor more drier conditions than wetter conditions. You can see that overall, throughout much of the Midwest, getting back to Minnesota, we're not expecting to see any major disruptive winter storms over the next 10 days or so. I like to show you what's going on. You ready? This is the European model. What we're going to see here as we play from Monday into Tuesday and Wednesday, there's not a whole lot going on. Even by Wednesday, getting into Thanksgiving, don't be surprised if there's a little bit of light snow showers here, but that's all we're seeing. This is, again, Wednesday night into Thursday morning. That system pulls on out, and there's maybe another brief little clipper that comes through on Friday, bringing a little bit of snow, but you don't see any major weather systems setting up through. I'll just keep playing this out quickly. Nothing coming through the next 10 days. So we have little chances of getting disruptive weather, small chances of getting really disruptive weather. But wait until you see what your temperatures are going to do. Here's today on Monday, but as we play this forward, ready? Tuesday, really, really warm. 50s possibly in southern Minnesota, but don't get used to it because there's Wednesday, and then Thursday, you're back for a high on Thanksgiving in the 20s. So enjoy the warm weather beforehand because colder air is coming through, but it's not going to stick around. There's Friday, getting into Saturday, going back over toward more mild conditions in the mid to upper 30s. And Sunday, possibly cracking 40 in southern Minnesota. So we've got some warmer weather that's going to come around. And take a look at this. The main drivers, and we're going to finish up with this for our forecast, is this La Nina right here, the cold water in the North Pacific, and the fact that the trade winds are coming out of this direction quickly here, and we got westerly winds coming across the Indian Ocean. That makes a lot of rising motion in what we call MJO phase 5 right there. I tried to write the number 5. But you need to keep an eye on the cold water here and the cold water here that's associated with our La Nina. Because as we look forward, where those strong trade winds are meeting up with the westerly winds coming out of the Indian Ocean, is right here on that line, right there. So the blues are the trades. The reds are where we got these westerly anomalous winds, and they're starting off over 5 and they're moving toward phase 6 and 7. Now, why talk about that? Well, the MJO coming out of the Indian Ocean might be the most dominant factor in the flow of the atmosphere right now. It's going to just curl around just like this. You can see the numbers, phase 4 to phase 5 to phase 6 and phase 7. Now, why does that matter? Well, if the MJO, which is spurred along by La Nina, is going to control our weather, while it's in phase 5, the coldest air is here, here, and over Europe. Now, if the flow has to go around that, look, it's coming out of the northwest right now, which means we get shots at colder air, just shots of them. It's also dry. Northwest flow coming from Canada doesn't produce a lot of heavy rain or snow. But if that ridge begins to move a bit, so this is what it looks like by the time we get to this weekend. If we move this ridge out of the way, take a look. We start to get some bigger, broader flow, bringing in warmer conditions as we progress forward, and the cold air stays east. So it looks as though the very end of the month of November, getting into the beginning of December, keeps all the cold air here and warmer conditions there. Take a look at this. This is the beginning of December. So if you're planning to take off a little bit of time to finish November and start December, Keith, you gonna split some wood? You might have some decently warm weather during that time period. Do not get used to this because it's going to change. Precipitation-wise, near normal, all the way out here to the beginning of December. But what about beyond that? When do we start seeing the snow fly and the nasty conditions return? Because in Minnesota, we understand that all of this is possible, right? That snow can start to whip that wind, or the wind can start to whip that snow around and pile it up against the front of the garage. We can get some pretty nasty snowstorms our way. And sometimes if we don't get this, we get problems with ice. This was a video from 2019 where this guy here, this UPS delivery man, just has to get this package, but he cannot get up the driveway. I think you should try out for one of our, here you go, one of our curling teams, right? That was a pretty good push there. And he just scoots his way back on down to the truck because of that ice. Well, here you go. As we wrap this up, December's outlook. Okay, mild start gives back way again to some colder air coming out of the Canadian prairie. And I think you're going to see some good early season snowfall as well. The chances of it being below average or drier than normal are not high. Better chances of seeing above average precipitation. Let's keep going. Europe. There's a lot of questions about the demand on natural gas. If the eastern United States, which you just saw here, and Europe remain cold, the demand side of the natural gas supply-demand equation is going to continue to stay high because we have major population centers in Europe and in the United States that are going to favor colder conditions. But as I told you, we got to watch out for these ocean temperatures here and here. Because historically, when it's colder in those areas, I tell you what, just look in the interest of time at the graphic over here. November through March, we tend to be snowy along the northern border of the United States. It tends to be drier in the plains, in the southern plains, drier in the southeast. And guess what? Icy and snowy through the Ohio River Valley. To be honest, that's exactly what the Farmer's Almanac said it was going to be this year. I wonder if they looked at this or maybe heard one of my forecast videos and changed it up. Because it looks like, given the fact that we're going to be bottoming out on a La Nina here, that we should expect to see these kind of conditions. Near normal to above average snow here, same thing through here. And as you get over into the northern plains, we could also see some correction on the longer term drought situation. Now, speaking of longer term, December, January, February, wherever you see these shades of green, that would be above normal precipitation. It tends to be drier in both models across the South, wetter in the Ohio River Valley and wetter at times in the upper Midwest. So coming back to the beginning here, if La Nina dominates, which we expect it to do, I think you're going to get a pretty good workout of your snow shovel this year. I think it's going to be a good year where we're going to get some good, hard, deep freezes into the soil, which is good overall. And overall, I think this is going to be corrective on the longer term drought scenario. NOAA agrees with me here. They've showed this area that drought should be improving in this region going forward. And that is a very, very good sign. Not so much in the southern plains and in the Four Corner states, but better drought improvement in that area. NOAA agrees with all of this. You can see that when the cold air comes out, right where it's going to be coming from, the Canadian prairie, right? See that? They favor warmer conditions along the south, warmer conditions in the east. But I'm not so sure about this over here on the east at all. The south I agree with, but not in the east. Above normal precipitation to near normal across the state of Minnesota. That's the longer range outlook from NOAA at this point. And to finish this up, I want to show you what's going on in South America, and then if there's time for questions, we'll take them. Unlike a year ago where drought really ravaged parts of Brazil, that's not been the case this year. In Mato Grosso, not only have we increased acreage, in fact, the whole of Brazil added around 4 million acres this year, but we planted at a near record fast pace, way outside of the past 5 years. We're already completely planted in Mato Grosso. If you are unaware of how big Mato Grosso is, let me outline it for you. It's right here. See that? That's the state of Mato Grosso. I'm going to put 2 Minnesotas, 2 Iowas, and a Tennessee in there, just so you get how big of a growing area this is. And don't forget, they continue to grow. Goiás, Minas Gerais, Sao Paulo, through Paraná, Santa Catarina, down to Rio Grande do Sul, and don't forget about Mato Grosso do Sul. And then there's Uruguay, Paraguay, and Argentina. That's a big growing area as well. So this is a huge part of global agricultural productivity. And what I want you to think about and really pay attention to is this. A year ago at this point, we were in major deficit in soil moisture. Not this year. Not this year. Where could there be problems? Well, throughout December, everyone's going to watch this area. As I told you when I started this talk, I got into a discussion with our team of economists. And what we determined, what we had a discussion about was there's major risk for drought in Argentina when there's a La Nina. Argentina's not yet having problems, but we're worried about December, January, and February that it could. And the discussion there is people, the markets, the decisions made about this, there won't be anything changing until someone says the drought is there. So despite the forecast, until it verifies, this is a potential market story. We could really curtail the total productivity of Argentina should the drought develop there like it's been forecast. Because the long-range forecast for December, January, February in Argentina continues to be dry. And that might be the most important market news that I've got to share with you, that and the information on the natural gas market. This is what we're going to be watching. It's not a day-by-day forecast. Edward Lorenz would tell you that that's stupid. Don't try to do it. It's looking at longer-term deviations from average. And that is an area that we've improved incredibly over the last 70 years. So this is what we're going to be watching very carefully as we move forward in this forecast. Well, I tell you what, I'll be watching it. You don't have to watch it. And if you're interested, this is where you want to go to get it. info.nutrien.com/Snodgrass, that's just my last name, _weather. I produce a morning report every day. This is just a screenshot of one I grabbed back in July, where you can download long-range analysis. You can look at the near-term forecast with our national report. I provide commentary if you want to read it, or if you're a map junkie like I am, tons of maps to look at. You can even download the report like this just to see how it looks. So the idea here is that I want to provide free access to all the weather data that I look at and produce. And it is completely free. Nutrien lets me give it to you as a free resource. If you decide to sign up at info.nutrien.com/Snodgrass_weather, you can unsubscribe at any time. And all that will happen is you get put on my daily distribution list. And starting very soon, I'm going to be releasing those point forecast locations so you can get an eye on what's happening at your local area. And I'll just show you that, and then I'll wrap this up. Take a look. Ready? If I can get this, there it goes. I can show you an example here. This is how it'll work. When you come to this, I don't know, why don't we just pick out a location, Minneapolis. So you start typing it in, it gives you Minneapolis. There it is. It's ranked 15 in my index. So I click submit. And as I click submit here, it's going to start to produce the local forecast. Now I can go look at it immediately from the National Weather Service by clicking there, and you get your National Weather Service forecast day by day. This is exactly what you get from NOAA. But what we're doing also, it takes about 7 seconds to produce, is you get a second link on that page right here. When you click on that, you get a multi-model forecast generated on the fly of all of the different weather variables that growers care about. So high temperatures, low temperatures. You get multi-model forecast of precipitation. Notice how you don't see anything on these graphics? That's because I told you it's going to be dry for most of the next 10 days. So there's not a whole lot on these. But if you look down here, I got information on wind gusts and direction, your soil temperatures, dew point temperatures, all sorts of great stuff like that. And then what everybody likes to see is the history. So here is the precipitation history, the daily highs and lows compared to average, and the GDUs this year. So I just want to make sure that you'll know you get access to all of this completely for free if you want to get signed up for it. Keith, I've rambled on now for 56 minutes. I'd better turn this back over to you, but I appreciate the opportunity to come and talk to everybody today. Hopefully we found something out interesting and new today.
Thank you very much, Eric. I very much appreciate all the content and certainly the application to each of us as we're part of Farm Business Management, Minnesota Bankers, and this, farming in general, right? I'll put one last call out if there is any question out there. I haven't seen anything in the chat, Eric, which can mean a lot of different things, but I think you've probably overwhelmed a lot of us with the content. But very much appreciate you being here today. Any questions out there? And if somebody wanted to jump in and unmute, let's go ahead and do that. Otherwise, we're going to be bringing this to a close here in about 1 minute. While we're doing that, Eric, you want to come back, I think, share your comments fertilizer-wise that you shared earlier with me before the webinar began in earnest.
Yeah, absolutely. So so one of the more important things that was just announced is, we have the really high demand on natural gas, and there's supply issues just across the world with it. And Nutrien to step up and try to alleviate some of the pressures we've had with the fertilizer that Nutrien does the most mining of, which is potash, is they just announced an increase of 1 million metric tons of production just to ease those fertilizer prices back down. So it's really, that's good news. We want to hear as much of that as possible. I'll say this, I would ask that everybody on the call that be thinking about the fact that right now we still have good demand from China. We have potential problems coming out of Brazil, especially southern Brazil and Argentina. We still have high demand, and there could be some shifting of acres across the United States next year, which means I was talking to Gary Schnitke, which is also here from the University of Illinois, about where he thinks prices will be going into next year for two big crops, corn and soybeans. He thinks things are going to continue to be favorable. And he confessed, he goes, I'm not an optimist either. So that's at least another piece of good news, just to think that there's going to be some further support. But the reality of it is that I would be concerned about issues in India and China as well. And let me finish up with this. In India, there's massive air quality problems happening right now. So they have shut down some of their coal and natural gas plants, and shutting them down, that reduces a nitrogen source, right? In China, we have the worst air quality time of year is this time of year for them. Plus the Winter Olympics are coming up, and that plus relationship issues with Russia, plus the demand that the Chinese government has on its own fertilizer production could be a major factor going forward here. Plus they're having bad air quality issues right now as well. So I don't see a near term, despite what Nutrien is attempting to do to alleviate some of that, I just don't see a near term global change that's going to just drop those fertilizer prices back to where we want them. That Nutrien, we would do anything to make this a favorable environment for our customer growers, right? We want to supply that. We would rather not have crazy high prices, but instead supply the demand. So it's just something that I think we should all be on the lookout for. I did see a question come up here, Keith. It says ECM WF models, where to get them? You got to pay to get them unless you use my site. Okay, so Nutrien bought it, cost us $250,000 a year for me to make this for you. Okay, so let me show it to you, and then I think it'd be good to wrap this up. So when you sign up for my daily reports, you will get free access to this website. It's ag-weather.com/national. It's just my national page. And you'll see them all labeled. So if you'd like to see the European model forecast for precipitation, any of these links will take it to you there. So you just click on them and you'll get these really great slide bars. Sorry, my internet's a little slow while I'm on this meeting. And you can slide this forward to see all different weather changes. It's not just precipitation. I've got wind information on there. I've got jet stream level stuff on there. We've also got temperature forecasts. So if you want to see the temperature forecast from the European model, it's right here. You can click on it and you can see that forecast as a function of time as you go forward. So it's all there for free. We bought it. Otherwise, you have to pay quite a bit to get access to it, but it's there. Good question.
All right. Thank you, Eric. There was also a question on recordings that will come out through myself or Kim Phillipson from Minnesota Bankers. And again, a shout out to them for their sponsorship. Eric, very much appreciate your time, knowledge, wisdom today. We look forward to a relationship going forward. So thank you everyone for joining and have a good Thanksgiving.